E aí, galera, tudo bem? Boa tarde para todos vocês aí. Bom dia, boa noite. Não sei se você estiver assistindo a gravação, tá? Espero que você esteja gostando, tá? Esse evento aqui, galera, estou bem feliz, bem contente de poder trazer uma pessoa que eu conheci em um dos eventos que eu participei recentemente. O Alex é muito gente boa, ele conhece muito dessa parte aí de desenvolvimento em SQL Server, então eu convidei para fazer uma sessão aqui para a gente, tá? Então essa sessão dele é espetacular. Espero que vocês gostem. Eu não vou nem usar muito tempo, vou deixar que ele se apresente, que ele faça aí todas as demonstrações e mostre para vocês tudo que ele tem, todas as experiências que ele possa compartilhar, beleza? Eu vou estar por aqui, galera. A apresentação ela está em inglês, tudo bem? Se você tiver algum problema, alguma dificuldade para fazer alguma pergunta, é só você colocar aí no chat. Aí eu ajudo, eu traduzo, depois eu encaminho para o Alex, beleza? Então vamos lá, galera. Espero que vocês curtam. Obrigado para todo mundo que está online. Obrigado você que está assistindo a gravação. So, hi Alex again. Thank you for your time. I'm sure that you have a lot of good information for us here in Brazil. So I will pass for you and I'll be here. So if you need anything, you can just ask me and we can take a look. Okay, thank you again, man.
Thank you. Thank you very much for having me. And it is so cool to get to speak to your user group in Brazil. It is kind of weird for me because I neither see myself nor I see the audience, but this is going to be fun. And welcome to this session called SQL Server Hates You, with a question mark. What the DBA never told the developers. And I'm very happy that you're here, and I'm equally happy that you want to find out just how evil SQL Server can and will be. So it just started with a phone call. I was sitting in my office, just happy as a clam. Everything was quiet, and out of the blue, there was a phone call. And I looked at the screen, and I saw that it was a friend of mine who's a developer. So I picked it up and said, hello. And it was dead silent. And just when you start to think that maybe I should say something, I pretty much hear a scream, SQL Server hates me. And it kind of stopped me in my tracks. I started thinking about this, and I realized that no, SQL Server doesn't hate you specifically. It hates everyone. And that was the inspiration to create this session. Because as with any profession, it is quite easy to get stuck within your own boxes. A developer doesn't really need to think about how the database does stuff, as long as the code works, right? No, wrong. Knowing a bit more about how SQL Server can be domesticated will elevate you from a mere programmer to a developer demigod-ish. In order to move skywards, though, you will need to dig deeper. You need to get a better grasp of how the database engine does things under the hood and appreciate why some of the techniques come with a pretty hefty price tag. This hour is but a taste of the things out there, but now, buckle up. We are leaving Kansas. My name is Alexander. I've been doing this for 20 years, give or take. I started working in 1997. The thing is that I started out as a paramedic before I kind of got to my senses and started toying with database stuff instead. I've spent pretty much all my time with databases, primarily Oracle and SQL Server. And my my first gig was a developer. And let's be honest here, everybody is very happy that I am no longer a developer. I live in Linköping in Sweden, and I spend my time doing pretty much anything with data for Atea in Sweden. We're a fairly large company, 2,000 people in Sweden and around 6,000 in Europe. I hold a bunch of certifications. I do a podcast with my friend, knee deep in tech, and I go pretty much all around Europe doing sessions. And that was basically how I met Vitor in Israel. Lots of fun stuff. And I'm quite a serious Star Wars fan. And while this session does not include very much Star Wars stuff, let's say that I'm a serious Star Wars fan, as in very serious Star Wars fan. Now, let's start with the story of gluttony. SQL Server and my cats have one thing in common. SQL Server approaches memory as my cats approaches food, as in, give it all to me. So I'll give you a number. This is a pretty big number. And here I usually ask the audience, do you know what this number is? And some people laugh, some people scratch their head, and some people basically just shake their head. And then I say, I'll give you a hint. It's in megabytes. This is where most people sit up and take notice, because this is a heck of a lot of megabytes. And it turns out that this number is the amount of memory that SQL Server will take as an upper limit out of the box. And very few of my customers have this much RAM, as in none of my customers has this much RAM. And let's take a step back for a moment and look at what memory is used for. We all know about the SQL Server, but in a perfect world where we would have only SQL Server on our box, yeah, about that perfect world, it doesn't exist. In many cases, we have other stuff such as analysis services or reporting services or integration services or any combination of thereof. There is, by the way, a name for a server with everything installed. That name is a clown car. Don't do it, please. Just don't. It is a bad idea, because it turns out that each and every of these applications, which they basically are, require memory. This is basic stuff to a DBA. Every DBA worth his salt knows that this is the case. Devs? No, not necessarily, because this is not their shtick. This is not what they do. So what about this memory stuff? How do you actually keep SQL Server from eating all your memory, and how should you think when it comes to setting memory limits? Well, let's take a look at what's in there actually. We know about the buffer cache. This is pretty much where the magic happens, because this is where all the blocks that you use go into. This is where you read data from. And if you're not finding stuff in the buffer cache, the SQL Server will go out to the disk and fetch it for you and put it into the buffer cache, and you're going to get it back. But there are quite a few other memory structures in a SQL Server. And this is, by not a long stretch, all of them. This is just an example. So about that memory stuff again, there is a setting called max server memory. If you don't set it, it defaults to that huge number that I just showed you, which kind of sucks. So we're going to set it. But what does this actually control? And how much memory can you use in a SQL Server? I usually work with clients and customers in Sweden, in around Sweden, and it's pretty much the same all around Europe. We tend to prefer the standard edition as opposed to the expensive edition of SQL Server. The standard edition comes with a few gotchas, such as a max memory limitation. And depending on your version, it is different. Up to and including 2012, it's going to be 64 gigabytes, and 2012 and upwards, it's 128 gigabytes. But what does it control? Here's a catch. The max server memory only controls this. It only sets the maximum size of the buffer cache. So what does this mean? Well, it turns out that I can have a box. Let's say we have a SQL Server 20, let's go with the 2014 or 2016. How much memory can I actually cram into a box and have the memory used? Well, what do you think? Some are going to say 128 gigs, period. That's the maximum for SQL Server. Yes, it is. But again, you're going to find yourself having other things on the machine, such as an operating system. Let's take a look at this. If I put in 160 gigs into the machine, and I set a maximum server memory of 136 gigs. Wait, what? Maximum server memory can only be 128 gigs. No, that's not true. The maximum size that the buffer cache is going to be is 128 gigs. So by setting maximum server memory to 136 gigs, we reserve some space for the other things that go into memory. Fair enough, but the memory that is left when you subtract 136 from 160 gigs, where does that go? Well, that goes to the operating system. If you've been doing this for a while, which I have, I started out with Windows NT 4. That was interesting, and it turns out that I am no longer 20 years old, but let's leave that. Back in 2003, Windows Server had an interesting behavior if the operating system could not get memory back if it was allocated to a process and that process did not relinquish memory upon command. Windows 2003 died, period. It just keeled over and died. And a great blue screen. That is usually not appreciated in a business. I say usually, but yeah, most of my clients would frown upon a blue screen here and there. So moving up, 2008 and 2012 behaves slightly better, but if you lock memory in place, you might get bit if the operating system cannot get enough memory for itself. Thus, never commit all your memory to SQL Server. And there is something we had not talked about, and that is lock pages in memory, which is a whole different kettle of fish. That means that you're actually pinning all the memory that SQL Server is using into memory, and the operating system cannot take that memory back. That means it's even more important that you do not commit memory that you don't have. So treat your operating system with respect and never, ever leave the maximum memory at the default setting. Okay. Moving on to a pet peeve of mine, which is called parallelism. And I chose this picture for a reason. And it's probably going to be pretty obvious in just a few seconds. I'm sure everyone has seen the dreaded CX packet. What is the CX packet? That is called the class exchange packet. And CX packet is not the issue. It is a symptom. Remember, I used to be a paramedic. You can either treat the symptom or you can treat the underlying condition. Most of the time, treating the underlying condition gives the patient a much better chance for survival. And it is exactly the same thing with CX packet and parallelism in SQL Server. You're going to go bonkers if you go out on Google and just check how many people say, oh, you have parallelism, that's an issue, just turn it off. And your CX packet's going to go away. And I say, yes, they are going to go away because your parallelism just went out the window. Is that a bad thing or a good thing? Yes, it is. I'm going to have to say yes. Right. So what is this darn CX packet? What is it all about? This is what you see when the optimizer is trying to put all the pieces of a parallelized, that's a very difficult word, parallelized, you know what I mean, operation. Because let's take, for instance, a bag of Skittles. We have many different colors of Skittles. Either I just pour the whole thing into a big bowl, and I start to sort. I'm going to have the red ones over here. I'm going to go with the blue ones here and the green ones over there. It's going to be a while, but it's okay. I don't have anything else to do. But if I decide to take this operation and turn it into this, bits and pieces, as in, I'm going to give you 10 Skittles, I'm going to give you 10 Skittles, and I'm going to give the guy over there 10 Skittles. Then you can sort them and give me back the result. That is what parallelism is about. And CX packet is something you're going to see when the guy in the back fell asleep and didn't bother to count his Skittles. So 2 of you have already completed your counting tasks. I'm waiting patiently for the third guy to actually wake up and give me the result. Thus, we're going to see waits on CX packet. That's an issue, right? So how do we control this parallelism stuff? Well, there are 2 main settings. The first one is called max DOP, max degrees of parallelism. And the default setting, as is often the case with SQL Server, is completely insane. It is 0. That means it's going to try to parallelize everything it sees. All CPUs will be used in a parallelized process. That's an issue, and I'm going to explain why. This is a computer, and for some of you, you might recognize this specific computer. This is a Dell Dimension Pentium 2 from the late 90s. This specific machine is the machine of Gene Amdahl, the guy at Microsoft that built the code for the optimizer and the cost analysis tool for the optimizer. And it's pretty basic. It works like this. Something that takes 5 seconds to run on this specific machine will give you a query cost of 5. With me so far? Okay. Now, it turns out that there has been some developments when it comes to hardware since the late 90s. So something that took 5 seconds in this box does not take 5 seconds on my machine or my laptop or my iPad for that matter. What can we glean from this? We can glean 2 things. The first is a cost of 5 is a completely arbitrary value. And it also means that you cannot, under any circumstances, compare 2 costs on 2 different machines. It's just numbers. They don't add up to anything. But what you can do is take a look at the cost of 2 queries on the same server and say if one is cheaper or more expensive than the other. Right. So with a max DOP of 0 and a cost threshold for parallelism, these are the basic settings set to 0 and 5. This means that SQL Server will try to parallelize on each and every CPU it sees, and it will do it for pretty much any query out there. So why is this a bad thing? It is due to how different queries behave in the optimizer. If we take the good example first, that would be a long-running query for a report or a data warehouse or something like that. then it is something that we probably want to parallelize. We want to chop it up in pieces and make sure that all our CPUs get something to do, because we actually bought the darn thing. So why don't we use all the CPUs? But if we look at the other end of the spectrum, not a data warehouse, but an online transaction processing database, such as take Amazon, for instance. That's an online transaction database. You're going to look at very short and very quick queries that don't benefit very much from parallelism. I say very much because there is always going to be outliers. Some queries are going to be faster or slower or whatever, and some are going to behave in a way that you actually want to have parallelism. But basically, most often you don't want parallelism in an online transaction processing database because you have a lot of users. Why don't you just burn one CPU for one user and leave the other CPUs for the other guys? So what do I do when I see settings like this? Well, first I scream. And when I'm done screaming, I say, hey, I can fix this for a slight price. So what do we do in this case? These are starting numbers. I cannot stress that enough. And every instance is unique and special and snowflake, and you know it. Test whatever you do, but this is what you can do. I set the max stop to 1, 2, or 4, depending on the number of CPUs I have and the expected load. Why would I set 1? Well, that means that there will be no parallelism whatsoever. And this is the case if you are running SharePoint. Because SharePoint, while being a great product, sucks underneath the covers. Yes, it does. Just look at the queries it creates. It is horrible. And it requires a max degree of parallelism set to 1. Back in the bad old days, before 2016, we could only set the max stop and the cost threshold for the whole instance, meaning that you did not want to put SharePoint on the same instance as something else, pretty much. 2016 and upwards, you have what is called the the database scoped parameter, which means that you can actually set the max stop and the cost threshold and other stuff for each and every database. That is much, much better. And again, depending on the number of CPUs, maybe you are going to use 2 or 4 for the max stop. It is your choice, and you need to test it before you do anything. So what about cost threshold? I set it to 50. And again, this is a starting number. There is a rule of thumb, which I unfortunately cannot tell you where it came from. I've just seen it, and I can't for the life of me find out why. That says that if you can have roughly 50% or maybe just below 50% of your queries go parallel, then maybe you have an optimized situation. It is a very wide latitude for that recommendation, but it is something to keep in track of. So I set this to 50, and then when the system has been running for a while, I go into the plan cache and check how much is the costs for the different queries, and I adjust this number upwards or downwards depending on the average cost. One final word of warning, though. You can change these on the fly. You don't need to restart the instance. You don't need to restart the server. But if you do, be aware that changing the max stop or changing cost threshold is going to blow out your cache. Yep, you heard it right. The buffer cache is going to be cleared. Nobody's going to tell you this. You're not going to see any warning messages. It's just going to happen. And this is Unix style. It doesn't ask you. If you say, I want to change max stop, SQL Server will say, yes, sir, and clear your cache. So be aware of that, because it's probably going to change your performance for a while until the cache gets warmed up again. Right. Moving on, my friend called me up again, and he said that his I/O performance sucked. And it turned out that he was referring to the public toilet of SQL Server, the Temp TB. The public toilet of SQL Server, I don't know who actually coined that thing. Maybe it was Brand Ozar, or maybe it was Klaus Aschenbrenner. Both are very interesting to listen to when it comes to Temp TB. But Temp TB is one of the worst kept things in SQL Server. Whenever I ask my clients or my audience this, say all your database disks are spinning disks, but you can have one disk to be an SSD, solid state drive, or NVMe or whatever. It's a much, much faster drive. What would you put on it? It's usually, I get 60 to 70% people say, yes, put the logs on it. The remainder say put the database on it, and nobody says put the Temp TB on it. And here's the kicker: always put the Temp TB on the fastest drive. Just do it. It's going to give you much, much better performance for several reasons. Because here's the thing: everything happens in Temp TB. Sorting happens in Temp TB. Spills happen in Temp TB. The list couldn't be humongous. And here again, we have a default setting that is utter crap. Up until 2016, you're going to have one Temp TB. So how many Temp TBs should you have? Well, I'm very happy you asked that question, because it turns out it depends. Yeah, heard that? Well, it depends on how many CPUs do you have. And this has been quite contentious thing for many, many years. But in the end, Bob Ward, one of the absolute masters of SQL Server, decided to actually check this out once and for all. How do you size and how many Temp TB files should you have? And it's pretty easy. Just use one Temp TB file per core, up to 8. If you have more issues, keep going, 4 more. If you still have issues, keep going, 4 more. And if you have issues with 16 Temp TB databases, yeah, give him a call. So, what's this all about? It's all about contention. We have 3 things inside, or we actually have a lot of things, but these are the 3 main things that are going to be an issue in a Temp TB file. We have the GAM, the SGAM, and the PFS. The GAM is the global allocation map, which we have in 64K extents. We basically have one per 4 gigs. We have one shared global allocation map per 4 gigs, and every 8,088 pages, we have a page free space. So we're going to have a few pages or things inside these files that everything is going to need to write to, because we're going to need to know, where do I find free space and which block or page is available for me to use. So what we are stuck with when everything starts happening is this. We pretty much have a festival. Everybody wants to do everything at the same time while wearing strange clothes, drinking a lot of beer, and just behaving irrationally. Yeah. So what do we get from having more files? Well, we go from this, where everyone and their cat want to access the same structures, to this, where we have a lot more structures and the contention and issues are spread out over several files. Much better. And your clients and your customers are going to love you for this one. Oh, yeah. A word of warning, though. Up until 2016, you need to set a few trace flags. Trace flag 1117 and 1118 are going to give you most performance boost. Look them up, because you want to see exactly what they do before you set them, and it's going to be quite some time for me to explain them. So 11.17 and 11.18. Keep in mind, though, that these are default on 2016 and upwards. And while we're at file settings, if I ever find any of you setting file growth settings to %, I'm going to haunt you. Friends, don't let friends set their file growth settings to %. Always set them to a specific number in megabytes or gigabytes or terabytes if that works for you. But be sure to set a specific number. Never ever use %. Right. So let's keep going. It is time to bring in, I was about to say an old friend of mine, the my bad days from a developer point of view. How much tuning can we actually do on the database before we start poking around with the code? Depending on who you ask, you're going to have different answers. And in my view, you're going to have the biggest impact if you can actually touch the code. But it turns out that there is something called a bad code. And there are some things that look like a great idea from a SQL Server or developer perspective, but it isn't. It isn't at all. I'm going to give you a quick overview of my test setup. This is just 1 million rows in one table. I have one clustered and one heap index. So you have a small idea what this is about. Right. There are a few ways to write a function. Functions are good stuff, and pretty much every developer knows what a function is and like to use functions to encapsulate and make things a lot easier for accessing data. And you can always change the definition of a function, but if you keep the name, you're not going to need to change any references. You know the drill. Well, there are many ways to do functions, and depending on how you do your function, you're going to have some very interesting effects. There are basically three kinds of user-defined functions. You have scalar, which means that you get exactly one result back, inline table valued, and multi-statement table valued functions. Well, the scalar, they are easy. One return variable of the scalar type. The other two, let's look at them in reverse order and start with the multi-statement table valued function. This is a multi-statement table valued function. Say that 5 times quickly. What it does in this case is that it does a cursor and it does some code and returns a result. And what makes this a multi-statement is that we do several things inside this function. We open the cursor, we fetch, and we do a while, and we close and deallocate. Right. I'm actually doing the wrong cursor. Sorry, the wrong slide. What I meant to say was, what we have to the left is an example of how the mind works. Because it turns out that the human mind is not very good at handling sets at all. Let's take an example. Have you ever done laundry? And you'd be surprised how many people actually say, no, I have not. But I'm going to take it as a given that you guys have actually done laundry. And there are a few ways to approach laundry. One way is to take a garment, fold the garment, put it in the closet. Then you take the next garment and you fold the garment and you put the garment in the cupboard. Then you take the next, yada, yada, yada. What we're basically doing is a cursor. This is the way the mind works. This is how we approach doing repetitive things. To the right, you can see a set-based operation. In this case, update products set price equals price times 1.1, where product type equals 1. The two code examples do the exact same thing, but opposed to take garment, fold garment, put garment away, we just say take all the stuff out of the darn washing machine. if we can do things with a set-based approach, we should do things with a set-based approach. I'll prove it to you. The left one is called R bar, by the way, row by agonizing row. As you can clearly see in this case, these are two pretty simple SQL examples. No. It doesn't matter what these do. Just bear with me here. There was something called the Fill Factors SQL Speed Free competition a couple of years back. And the task was to produce a report by month listing the number of new subscriptions, the number of subscribers who have left, a running total of current subscribers. The left, in the example in this case, uses an R-bar approach with a temporary table. The right one uses a CTE, a common table expression, and some pretty clever set-based trickery. And this, by the way, was done by a Swedish guy by the name Peter Larsson, Peso called. And as I said, the left is a R-bar, row by agonizing row, and it took 126 seconds as opposed to the set-based version that took 1 second. Yes, people, 1 second. So top tip, if you can use a set-based approach to solve your problems, do so. It is slightly harder on the brain, and your brain might explode, but your performance is going to be much, much better. Right. Back to the example with the multi-statement function. Here we have a multi-statement function. Multi-statement table valued function. Table valued function means that you are going to get a table back. As you can see in the bottom, we're going to do select from this function with a where statement. And we're going to get back a virtual table. That's the case of a table valued function. But as we do more than one thing inside, we're going to do insert and we're going to do an if. That means it's a table valued multi-statement table valued functions. And why is this an issue? Well, there's something called statistics. Statistics is the only way for the optimizer to have a clue about how many rows your query is actually going to hit. And if your statistics suck, your performance will suck in equal measure. So why is this an issue? Well, it turns out that with a multi-statement table value function, SQL Server has no choice but to take an arbitrary number, which I'll come back to, and say this is the number of rows you're going to hit, period. Which is an issue. Because up to 2014, SQL Server is going to expect your query to access 1 row. Yeah, you heard me. 1 row. That means if you have thousands or hundreds of thousands of rows, this is going to give you a very, very poorly performing query. As in very, very poorly performing query. But don't worry about it, because in 2014 and upwards, it's kind of fixed. They've changed the number from 1 to 100 rows. Oh, shit. Nobody gives a crap about that. You're not going to win anything going up to 2014 or upwards. But here's the key. In vNext, that's probably going to be either 2018 or 2019, there is some very, very clever math going on underneath. So this might be a thing of the past going forward from the next version. We're not sure that it's going to be included, but I've seen some of the stuff and it is just, it blows your socks off. I have no idea how it actually works, but it does. So maybe we're going to see some changes. To the right, you're going to see 67 logical reads, and the whole shebang took 133 milliseconds. Right. So how can we make this better? Well, we can get rid of the whole multi-statement crap to start with. So let's do this instead. We remove the whole multi-statement thing. It is just one thing. This can easily be translated by the optimizer into something much easier, and it can actually use the stuff that's actually in the table. And it knows this by looking at the, I just lost the word. I am getting old. Statistics is the word. And as you can see, we are looking at 3 logical reads as opposed to 67 logical reads and no time at all. So this is how you do it. Go away from the multi-statement stuff and go with an inline table valued function or a single statement table valued function. Okay. There's also something called the sargable, the search argument able. And sargable means that SQL Server can perform an index seek using your search predicates. Brent Ozar put it that way, and it was a good way of putting it, so I stole it. Thanks, Brent. Let's take an example and see what happens. We have this query, select something, 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 where here date joined is 1953. This is not sargable because I'm using a function call in my where statement. And a function call in my where statement makes it impossible for SQL Server to actually use the index that I have on date joined, because the index does not contain just the year. It contains all the data in date joined, right? So what happens is we're going to see an index scan. Index scan is slightly, emphasis on slightly, better than a full table scan, but it's probably going to be the same thing anyways. So we need to scan each and every row to give me back the result, right? And as you saw, I have, let's see if this works. I have number of rows read, 1 million. And the number of rows that I need, let's see, is 1. Or no, there we go. Estimated number of rows, 9,000. But I need to read all of them anyways, because I don't have a clue. Is there a way to get around this? Yes, if you're running Oracle, you have something called a function-based index, and you can do something similar with other ways in SQL Server, but I don't recommend it. Be very careful with this. Try to rewrite your code instead. So speaking of rewriting code, see what happens in this case. We have the same query, but in this case, we're using convert. And 21 is the specific, what do you call it? Specific date time part when you do convert. Just look at the documentation. In this case, I am comparing date joined in its raw form to a number. This means that I can actually do an index seek as opposed to an index scan. Seeks are usually a better thing. And as you can see, I am going to expect 1 row as opposed to 1 million rows. This is going to be slightly quicker. Just do the math. I mean, scale up. 1 million rows is not that much anymore. Back when I started, 1 million rows was a lot. But these days, we can have 1 billion rows or 10 billion rows. And that means that this is just going to hurt you more and more and more as you go upwards. So what happens if we try to do something like this? We're going to have a between. Well, if you do a between, when you say date joined between this and that, you need to be careful because between is inclusive by nature. And if your data type contains a clock or a time part, say for instance, it's a date time as opposed to just a date, you're going to have some time information as well. And that might skew your results if you're using between. It might actually surprise you that you're going to find rows that you did not expect. If you do this instead, and in this case, date joined as is just a date, you're going to be home safe. We are still looking at an index seek because a between or a similar operation is going to work just fine. And we have 381,000 rows. Much, much better than a million rows. Then we have the human mind again. I like the human mind. It is great, but it is also hideously stupid sometimes. We have a tendency to like ordered lists, which is fine. Picture yourself a telephone book. Back when I was young, we actually had thick books with phone numbers, the phone book. These days, they don't do phone books, and it's always an interesting discussion to have with young people. Have you ever seen a phone book? A what? Yeah, you have never seen a phone with a cord. Never mind. And the whole idea with the phone book is that you can actually go in and find the phone number for a specific name. And of course, this is ordered by most often last name. It would be hard to use a phone book that was not ordered. I give you that. But if you don't need to have the data ordered, do avoid it. Why? Well, I'll show you why. This is the exact same statement. The one at the top has an order by, the one below does not. This is the different costs. We're going to see a 95% total cost given to the sort and a 5% cost to the not sorted list. And what's worse, there is an exclamation mark on the sort. Why is this? Well, remember Temp TB. Yeah, it's going to come into play here because SQL Server, when it does the query parsing, it's going to take a look at the query and think long and hard about how much memory do I think I'm going to need for this. Yeah, it's going to come up with a number. Hopefully, it is a good number, and it's going to stick to that number. It cannot, under any circumstances, change, unless you're on 2017. But let me get back on that one. So that means if the query starts and it turns out that the optimizer has been completely off the rails and thinks that we're going to need much, much less memory than we actually need when we start to do this, I'm sorry, but that memory grant is not going to change. So the only way we can handle this is by putting things on disk, i.e. writing it to Temp TB. And remember, folks, if you have a slow disk on Temp TB, you're going to take stuff from memory, which is pretty fast, put it on a very slow disk, and your performance is going to go south. So that is also something bad. And while we're at bad stuff when it comes to sorting, it actually gets worse, because this is what is called a locking or a blocking, I should say, operator, meaning that if there is a sort, all parallelism goes away. You cannot parallelize a sort. It is just not possible. So if you had a great data warehousing query that was performing flawlessly and you put in a sort and bam, you're going to see serialized actions. That sucks. So in this case, we have a query cost of 34.5 as opposed to 2, quite different. And as I said, we did a spill to Temp TB. That hurts. Hurts, guys. This is what we saw. We have an estimated number of rows of 381,000 and the action number rows 380,000. So in this case, my statistics were pretty much spot on. And of course, use the tools you're given. I've seen so many variations on this theme. Actually, when I started out, I actually found a piece of code in the first system that I worked on that had the name get system date. Somebody had actually wrote a function to give you the system date without using the sysdate included function. It was very clever. It was a lot of math, and it was slow as molasses. And this was only because that developer had no idea that there was something actually built into the database. Duh. So use the tools you're given. This is a completely valid piece of code, but it is not the best way to do it. This is. By using having, we can do so much simpler things. Having means I can put a where statement on a scalar function, in this case count. Much better performance than the left one. Okay. We are leaving code and stepping into something called parameter sniffing. The first time I heard it, I thought it was parameter sneezing, but no, it is parameter sniffing. And this is something that very few developers have a clue what it is about. And when you tell them, they go pale. It's kind of cute though, but it's not good for performance. So here's the deal. We have the same function, in this case, sales.customer_transactions. And we have two different select statements with two different where clauses. And depending on which parameter value we put in, we're going to see vastly different query plans. So in the case of 401, we're going to see the above one. That means we want to do a clustered index scan because we're going to see pretty much all the rows. In the other one, we're going to see a nested loop because we won't be querying that many rows. Right. But here's the thing. If you run this one first, SQL Server will take a look at that query plan and lock that query plan in for this query, which is great if we do it the right way, like this. But if we do it for another value, we might see something like this. Estimated number of rows, 23,000. Action number of rows, 250. Ponder that for a moment. The statistics are great. Everything is hunky-dory, but SQL Server has decided to use the first query plan that it saw for that query. This is called query parameter sniffing. So how do you solve this? Well, it is not that easy to solve it in practice. There are many ways that you can solve it, but each and every solution has its own price. You can do optimize for unknown. That means it's going to redo the parsing every time it sees the query. It might be a good idea. You might put in a hard query plan for representative numbers that you know is going to be good. There are many different ways, and I recommend you to check out everything that Kendra Little has written on this subject. She is very, very good when it comes to query tuning and index use. We are moving on to isolation levels. This is pretty fun, and this is another part where devs don't have a clue. And it turns out not many DBAs do either, because we know this. That's the pessimistic locking strategy. There's something called a pessimistic and an optimistic locking strategy. Let me give you an example. The pessimistic locking strategy works like this. Say you have a bunch of pensioners that are going on a trip. They descend on the travel agent en masse and say, yep, we're going to go on a trip. We're going to go to Bahamas. No, we're going to go to Bermuda. No, I want to go to India. And they start thinking about where they actually want to go. So the travel agent has a few options here. If he decides to lock the trip that they are most likely to use when they're discussing how many are they going to be and where, when do they want to go, that's the pessimistic locking approach to stuff. But given that they can't decide, so after 10 minutes, they go, nah, screw this. We are going to play bowling instead. And they leave. And then you need to release the lock of the rows. And this means that if there were another team that wanted to get seats on this airplane, they could not do so because the rows were locked and, in essence, gone. The other way of doing things is the optimistic locking strategy. That means that it is a very cool cucumber in the shape of the travel agent. He's seen this before, and he knows that, nah, don't worry about it. They're gonna need a while to actually decide on things. So he does not lock anything. He does not reserve any seats on any aircraft. He patiently waits until they decide that, yeah, we're going to go to Bermudas and we're going to go tomorrow. And then he goes in and locks the rows, but it turns out that the airplane is full. Meh. So as you can hear, there are good and bad things in both choices. Now, we're pretty used to using read committed, right? That's the default setting for SQL Server. I recommend everyone to go to the read committed snapshot. That means that I can actually read a row that is being read by another query. Otherwise, you're going to lock stuff with just reads. You're going to have shared locks with reads. Now, read committed snapshot is going to put some strain on your Temp TB. So make sure that your Temp TB is up to snuff and your drives are good, because it's going to hurt you otherwise. But read up on read committed snapshot and optimistic locking. It is the bee's knees. You basically, in just a heartbeat, get rid of all your locking issues. It is not necessarily always a good thing, but read up on it. It can give you much, much better performance. And speaking of performance and locking, has anybody ever done this? Yeah, the NOLOCK hint. It is basically the go faster hint, because everything just goes faster with NOLOCK, right? Yeah. But here's the deal. NOLOCK is the same as read uncommitted. And this is where many people get scared. And you should get scared, because you're stepping away from the ACID stuff. You are maybe reading uncommitted data, which means that your results may not necessarily mirror actual reality. This is dangerous stuff. DBAs should only work with known things. And moving about into a minefield that is called the read uncommitted or NOLOCK is usually a bad thing. And it gets worse, because dirty reads is what most people think of when we're talking NOLOCK or read uncommitted. Dirty read is that you can read data that has not been committed, and the data could be rolled back after you've read it. So maybe you're going to read data that technically never existed. But you might actually miss rows because of the way an allocation scan works. Other transactions could actually move data that you haven't read yet, or move them to part where you already have read. And in that case, you're not going to see the data at all. In some cases, also due to the way allocation scan works, you might actually read the same row twice, or you might read multiple versions of the same row, or you get just a read error. Yeah. And if you're, I'm sorry to say this, dumb enough to actually use NOLOCK hints with DML, data manipulation language, insert, update, delete, you can also get an index corruption. Never do that, ever. So be very careful with NOLOCK. It might be a good idea, but don't use it as a knee-jerk reaction to locking or blocking. It is bad practice. We've talked just a bit about the read committed snapshot isolation, and this still means that schema S locks, schema shared locks are taken. This basically means that you can't change the definition of the table while you're reading it, which is usually a good thing. But you don't need to do any code changes in order to turn this on. This is a database level setting. And if you just set it, your performance is probably going to go up, your locking is going to go away, and yeah, you're going to raise. Everybody likes a raise. But row versioning is going to happen in Temp TB, which means that Temp TB in a highly concurrent system is going to be hammered. So if you did not have any IO issues in Temp TB before, you might get it while you do this. So you need to take care and you need to test before you implement this. And go read Paul White's blog. That is a good starting point when it comes to read committed snapshot isolation, RCSI. I usually ask if there are any questions, but we'll hold the questions to the end. Just a few more seconds. And here's the deal. Don't fall for the idea that the developers won't need any insight into the database. By just a few basic changes, your database solution can increase performance several times and use the tools you're given. There are DBAs and there are developers. Some say they don't mix, and there are indeed plenty of examples when they don't get along. In fact, some people claim that this image is the result of a fallout from an especially vicious argument between a developer and a DBA. But accepting that there is only so much one can keep track of, and that people that do great things on their own do even more epic stuff when they work together, is vital to professional development. With DBAs and developers working side by side, using the tools available, and using the tools in the intended way for maximum performance, good stuff happens. Often new ideas, spawned from the collaboration itself, can be a quantum leap. Take this new knowledge and use it to better your code and better your relation with your DBA. A bright future waits. My name is Alexander, and I thank you very much for your time. Vitor, let's open the floor for questions.
Hey, Alex. We don't have any questions yet, so maybe someone who sent something for email and I can forward to you, but until now we're good. But I want to let you know that it was an awesome session. It was amazing. I also invited some friends from Pifian, the company that I work at in Canada, to watch your session, because was amazing. It was really good, man. So thank you again. I know it's late for you, and I know, but thank you again. Was amazing. I hope we can have you again soon to show us something new, something else, anytime you want, because it was amazing, it was awesome.
Thank you very much, and thank you so much for having me. This was great fun, and sure, it's late, but this is what community work is all about. I love the SQL family, and this is just so much fun. Well, I'll crawl into bed, and take care, guys.
Thank you again, Alex. Have a great night. Valeu, galera. Obrigado por todos vocês que participaram. Espero que vocês tenham gostado. Qualquer dúvida, manda pra gente. A gente encaminha pro Alex ou encaminha direto pro e-mail do Alex. Thank you again, Alex. Have a great night. Bye-bye.
Guys. Bye.